Hello folks, so in this video we're going to talk about logarithms, which we introduced with that unboxing video that you saw previously, and we also talked about it in class a little bit, but I just want to use this video to kind of wrap everything up in a nice little bow. Okay, so again, the idea of the logarithm was that it's our answer to finding the inverse of an exponential function. So let's create some random exponential function. We'll say y equals 2 to the x. Okay. And excuse me, the way I like to think about this is, well, you know at this point that I like to draw pictures and utilize function machines, so I'm going to do that. So here's our function machine, y equals 2 to the x. Alrighty, so the idea with this function machine, let me drag this down a little bit, is that the inputs are exponents. So we input an exponent, x is an exponent, let's say exp for short, and the output is the answer. So I'm just going to call it the final answer, but it's the result of that exponentiation. So the y equals the final answer. Right there. What this would be then, again, this is the original function. The inverse then would just say, well, the inverse, we talked about how the inverse is created by just switching x and y. So the inverse then would be this. X equals 2 to the y. Now, this looks a little bit different, but if we think about it in terms of what the function machine would look like, that would just look like this. Well, our function machine is now x equals 2 to the y. And if the original function machine takes an exponent and spits out the final result, the input to the function machine would actually be the final answer, some final answer. And then what would the output be? Well, this would mean that the output is actually the exponent you needed to get to that final answer. And that's what y is, the exponent, exp. The way that we say this, or the way we rewrite this equation to isolate y, because that's usually what we it's just more preferable to us, just like how for the equation of a line we don't really like to use standard form as much. We usually like to use slope intercept, y equals mx plus b. So how do I turn this into an explicit equation, meaning just y equals something? We rewrite it using this thing called the logarithm. So the idea here is that it looks like this. Log base 2. So whatever the base of the exponent is, or whatever the base is down here. And you say base, log base 2 of, and this is where the final answer goes. This is called the argument. Here it's called the argument. Not really sure why it is called that, to be honest with you. X equals y. That's all this says. So again, the way that this is, the reason this is nice is because we're so used to seeing, okay, you input an x, you do a bunch of stuff on it, you do a bunch of stuff to it on one side of the equation, and whatever's left out, that's what y is. That's just the way we're used to seeing things. At least here in America. I don't know how other countries teach it. And so an example of this would be, let's say x equals 4. No, let's not use 4. We'll use 64. Okay. So now, well, the original equation in its exponential form, that's what this one is, exponential form. Exponential form. And this thing over here on the right side, it's what we call the logarithmic form. Logarithmic form. If I plug in x equals 64, well, the equation would then say that 64 is equal to 2 to the y. And so the output that comes out of our function machine, or I guess out the top, if I'm using this drawing, is just the exponent we need to get to 64. Starting with 2 again. 2 is our base. The way we would say this, in terms of using the logarithm, is that we would say that log base 2 of 64 is equal to y. And again, these just mean the same thing. They're just written differently. And so, well, the question is, what exponent do we need to turn 2 into 64? And that's going to be, let's see, I always kind of get thrown off here, but I do know that, let's see, 2 cubed is 8. But I need to multiply that by another 2 cubed because I know that 8 times 8 is 64. So if I square both of these, I'll get 2 to the 6 is actually equal to 64. Oops, sorry about that.
Stop.
Sorry about that. That was my phone going off. 2 to the 6th power is equal to 64. And this tells us then that y is equal to 6. Okay, so that's all a logarithm is. It's just the exponent that gets you to some final answer. If you want to generalize it again, let's generalize it. Log base b of x, I'll say, is equal to y. Again, this is synonymous with b to the y is equal to x. Okay, just a couple of things. Remember that at the end of the day, this is just a number. And so log base 2 of 64, again, that's just a number. That's just 6. And so if I wanted to, I could do something crazy like this. 5 plus log base, we'll change it up now. Log base 4 of 16, pretend. I can add those two, those are just two numbers, I'll just add them. And so let's see, this is 5 plus, well, this right here, this is the exponent we need where 2 to that power is 16. And so this number is really just 2. And so that equals 7. Alrighty. Hopefully this helped clear up any questions you might have had about logarithms. And then we'll do some examples and take a look at their properties in the next video. Or next couple videos, excuse me.